All right, so Friday we talked about parallel lines. What did you guys learn about the slopes of parallel lines?
They vary.
Huh? They don't vary. They're going to be the same. They have to be the same.
Vary means that they can change. They can change.
All right. Today we're going to talk about perpendicular lines. Perpendicular lines are lines that intersect to form right angles. Okay? There's something special about slopes of perpendicular lines, and I'm going to teach you about that right now. Perpendicular lines, if you take two lines that are perpendicular, the product, which means multiply, the product of their slopes is -1. So if you multiply two slopes of perpendicular lines, you will get -1. Now, something that happens when you have a product of -1, opposite reciprocals will give you a product of -1. Opposite reciprocals, an example. It just helps to show you an example of what I mean by opposite reciprocal. Let's say we have a line that has a slope of 1/2. All right, I want to find the slope of a line perpendicular to 1/2. We do opposite reciprocal. That means we flip the fraction. Reciprocal means flip the fraction. Opposite means change the sign. So the opposite reciprocal of 1/2, we change the sign to negative and we flip it. So -2/1 would be the opposite reciprocal. So that's what I mean by opposite reciprocal. Let's say I have another example. How about I have 3? What would be the opposite reciprocal of 3? -1/3. Yeah, because this is 3/1, right? So then it's -1/3. So those are examples of opposite reciprocals. And slopes of perpendicular lines, they won't be the same this time. They'll be opposite reciprocals of one another. Okay, so we had the same types of problems that we did on Friday, only this time, instead of using the same slope, we're going to use the opposite reciprocal slope. Okay? So let's look at our first example. Write an equation of a line that is perpendicular to y equals 5x plus 3 and contains the point 0, -2. All right, so we want to write the equation of a line that is perpendicular to this line, okay? We already have an equation here. We can find out what the slope is from it. What is our slope on that line? Okay, our slope is 5 on this line. But if I want to write the equation of a line perpendicular to that one, what would my slope be? -1/5. The opposite reciprocal is -1/5. So we actually want to use this slope with this point. This is our x1 and our y1. We have a point and a slope that we plug into point slope form. Point slope form again is y minus y1 equals m parentheses x minus x1. So we plug in our m, our x1, and our y1 into the equation. So we get y minus y1. y1 is what? -2. Equals m, which is -1/5. And then x minus 0. Okay, I'm going to do one more thing. What is it that I want to fix up here? What's not right? The double negative here. Let's go ahead and make that positive. So the equation is y plus 2 equals -1/5 x, or parentheses, x minus 0. So here we have the equation of a line that is perpendicular to the one that they give us. That's all you have to do. The only reason we use this equation right here is to pull the slope out of it and then to do the opposite reciprocal. We don't need anything else from it. Once we get the slope, we're done with the equation. And now we write a new equation with our new slope and the point that it goes through. Any questions on example 1? All right, let's move on to example 2. The next example asks us to find out if the two lines are parallel, perpendicular, or neither. So what we need to do is we need to look at the slopes of each of those lines. Now, in order to be able to know what a slope is, we have to have it in a form that is helpful for us to pull the slope out of. That's y equals mx plus b. So we need to pull the m and compare them. If it's not in slope-intercept form, you got to get it in that form. Okay? The left one, is that one in slope-intercept form? Yes, it is. What is the slope out of this equation?
4.
4. So our slope is 4. How about example 2, or I'm sorry, equation 2? Is that in slope-intercept form?
No.
No, it's not. We need to get the y by itself. So we need to add 4 to each side of that equation. We cancel those out. We're going to get y equals negative 1/4 x and then plus 4. Now is it in slope-intercept form?
Yeah.
It is. What's the slope? Is it just 1/4?
Negative.
Negative 1/4. So
Do we really have to add that 4 if we use that negative 1/4?
I would rather you just go ahead and get in slope-intercept form because you might never know. Okay. 4 and then negative 1/4. Would those be slopes of parallel lines? No, because they have to be the same. Is it the slope of perpendicular lines? Yes, no?
Yes.
Yes, it is, because we have 4/1, and that's negative 1/4. So that tells us these lines are perpendicular. The important thing on these problems is to make sure these equations are in slope-intercept form first. If they're not, you got to get them that way. Okay. Write the equation of a line that goes through 6, -2 and is perpendicular to the line that goes through points 4, 5, 2, 1. Here's what we have going on right now. We want to write the equation of a line that goes through this point. So we know this is our x1 and our y1 because this point is on the line that we want to write an equation for. We know that we also want to write the equation of a line perpendicular to the line that goes through these 2 points. Well, in order to find out what the slope of a line perpendicular to these 2 points is, what do we have to do with these 2 points? We have to find the slope. So the very first thing we need to do is find the slope of this line right here. So we're going to do y2 minus y1 over x2 minus x1. That x looks like a y. Or that y looks like an x, rather. Now, this is a different x1, y1 than this up here. This is with our new line, so we're going to ignore that right here for a minute. And we're just going to focus on these 2 points right here. We'll call this one x1, y1, and this one x2, y2. So we plug it into our formula. y2 minus y1, we get 1 minus 5 over 2 minus 4. On the numerator, 1 minus 5 will give us a negative 4. 2 minus 4 will give us a negative 2. And then negative 4 divided by negative 2 is what? Positive 2. So the slope for this line right here, the slope for this line is 2. So what is the slope of a line that we want to write the equation for? This is the point that it goes through. What would we want the slope to be for our new line? If we want it to be perpendicular. Right, we take the opposite reciprocal of 2. So our slope for the new line is going to be negative 1/2. So these are the two. We're going to use 6, negative 2 for x1, y1, and negative 1/2 for m. All we needed out of this section of problem, out of this part of the problem, all we needed was to get this slope, and then we're done with this part. So now we focus on our new line. We've got the slope to our new line, and we have the point. So we can go to the point slope formula. Y minus y1 equals m parentheses x minus x1. All right, so we have y minus, okay, y1 is negative 2. So I'm going to go ahead and just make that y plus 2 because I know there's going to be a double negative. Equals m, which is negative 1/2, parentheses x minus 6. So there's our equation to a line perpendicular to the line that has these 2 points. Now, I'm going to have you guys do one more step on this one because in your homework, some of these you're going to have to get them to slope-intercept form. This is point-slope form. How do we get it from point-slope to slope-intercept? What would I need to do with that equation over there? Do the distributive property. Okay. First, get rid of the parentheses and do the distributive property. So we're going to get y plus 2 equals negative 1/2 times x, which is negative 1/2 x. What's negative 1/2 times negative 6? Is it positive or negative? Positive. positive, and then what's half times 6? 3. Now, we want to do what I think you were going to say. Subtract 2 from each side. So then we get y equals negative 1/2 x plus 1. And that is our equation in slope-intercept form. So some of them you will have to pay attention to the directions. Okay? Are there any questions on that example? All right.